Uncertainty?
Can we use the same diagram
As what?
as each other?
No, that is quite forbidden.
Diagram.
Yes,
If I reference the person who made it.
must be your own diagram.
Really?
Correct. You will receive a plagiarization penalty for doing this.
For a diagram.
If the diagram is not yours, if it was sourced from the internet
No, what if it was...
or from a classmate,
Yeah, from the internet.
still then you don't get marks for the diagram then.
But we're referencing it.
Yeah, so you're not being punished for it, you just don't get any marks for it.
But for the initial planning,
Yeah,
the diagram can be taken on the
you cannot.
There are two diagrams, right?
Why
Both of
two?
them need to be drawn.
Why two?
One in the initial planning, one in the procedure. Why?
But if you want to reuse the same diagram, that's fine. That's
But
fine.
we have only one in the procedure?
Yeah, the marking criteria doesn't even have the section for the initial planning. I think the initial planning is just the lab or whatever that is.
No, there is, well, complicated. There is an initial planning, but it might not be within the marking scheme of the lab report. I might have to mark it separately. And then I staple it with the markers report for the lab report. Anyway, there is an initial planning section because it's worth 10%. And I'm happy for people to include that in their lab report. And if you want to reuse the diagram, please do.
And
But it needs to be your own diagram.
if I don't include it in the lab report,
What?
then what's the other alternative?
There should be some diagram in your lab report.
I do have the diagram, but I don't have the section for initial planning.
Yeah,
But I
that's,
think it's kind of useless or pointless.
I know. Yes. Yes.
Everything that goes in the initial planning is basically the report.
Yes, it goes into the procedure.
Yeah.
Yeah. Could you at least make sure it's on its own page?
What's that?
As in, like, make sure it starts fresh on the page.
The what?
The planning. So at least I can say this page was the planning page. No, don't. You know what? Forget it. Doesn't matter. Doesn't matter. It's fine. It's fine. Okay. Yes.
When you talk about drawing your own diagrams,
Yes.
like you don't expect more than paint.
So yeah. Paint is you can do a lot with paint. As if you ever went to a website called a Mindbase. Yes. You can do a lot with Microsoft Paint. So this is all I expect from you. And you can put that on a t-shirt. I expect nothing more than Microsoft Paint from you. Okay, anything else?
Can we refer to like ourselves like as scientists?
No.
Like as in we're
No.
talking the experiment.
No.
What do we
No.
refer?
You do not refer to yourself. You do not exist in your lab report.
Yeah. Okay. So the scientist
No.
does that.
No.
It's like a man.
No.
So
No.
what do you write?
It is the
Yes. Yeah.
Carried out by who?
Don't write
No,
my
don't be causing problems for yourself.
There was one section for
was moved.
In the
for like the marking criteria or whatever the thing that you gave us in class. It was like 10% for initial planning.
no, I understand. That means that in the mark report I make for you, there isn't a section for referencing. But what will happen is, I can picture it now, is in the section for like theory or whatever, it'll be something like student introduces theory, which is clearly explained and has 3 references at the back or something. So
But this is the thing, it does say that, it says like references cited corrected,
yeah.
but it never mentions how many references.
Oh, you want to know how many you want? Go for 6.
Whoa! Hold your horses, cowboy.
It didn't even have 6 for our essay.
You want
How can I
write this by yourself and you want a reference.
Yes,
Look.
yes.
Lee,
You are smart.
Lee,
That doesn't add up.
Lee. I'm so sorry, but I am limited by what Manchester tell me to do. So if they tell me, make the lab report by yourself, but with 6 references, that's what I have to do.
And you just listen to them?
Well, I
Just
have
obey
to.
them?
Yes, I have to.
Another question.
Yes.
For, the
Now, this better not be a question that points out something ridiculous about the lab report. Go on.
In the analysis
Yes.
section, it says that the gradient should be determined correctly using a large triangle or square fit.
Yeah, no, delete the large triangle. It's using what I showed you in class, which is called the square fit, which is just the name of the method that Excel automatically uses.
Which is like y is equal to.
Large square, no, large square.
The Excel calculates the equation of the line. What you need to know is the process of how it got that answer is called the least squares method. You, as an engineering student, do not study this method in maths class, and therefore you don't need to know anything about it, whereas the business students do, and so do the science students. You know what I mean? So, amazingly, it's kind of a bit weird, but of the 3 streams, it's only the engineers that make use of the least squares in an actual coursework, and they are the only ones who don't have it as part of their math syllabus. Go figure. So, does that answer your question? Yes.
So basically, I can just leave it as y is equal to mx plus c.
Yeah, and Excel gets the M and the C. Yeah. And of course, obviously in the exam, you do not have access to Excel, so you will have to draw a large triangle on your graph and get the slope that way.
In the what?
A large triangle on your graph
In the what? In the what?
in the exam. Like if you were doing a question in the exam that had you make a graph and you needed the gradient, in the exam what they expect to see is you drawing a large triangle and measuring the height and the base, and the slope is the division of the two. That's what you would do in the exam. Now of course you don't do this in your lab report because that's stupid, because you have Excel. And Excel can make the line perfect for you. Okay, other questions? You want to sit beside me?
I want to discuss something.
Oh, that's interesting. You got a new theory to share with me?
No.
This is the theory of Newton and his similar identities. No, I don't care about this. I care about your lab report. I care so much as it needs to be finished and I will collect it.
How foolish.
Can I just
Let's do it.
It needs to be enough that I can say, see, he did it. I can prove it because look.
So if I wrote down my results, that's
Yeah.
do I need to have a graph? And it's not.
You're making it. See, the teacher part of me wants to say, no, do it properly, but if you're being technical about it, I suppose the results is enough. But you're going to make my life difficult because they say, Yusuf never did the experiment, prove it. I'm like, well look, he wrote numbers on a page. See? He so did it. And then they're going to say, why do you let your students do some stupid things in labs? And I said, look, I tried my best with this one guy, Yusuf. Wait till I tell you go. What am I looking at? You can pull up the chart. Right, after I answer Yusuf's question, what do you need me to do on the board?
Yeah, actually my question is about answer.
Yes, dude.
I did all of this
Good.
to get the
Good,
uncertainty value.
good, good.
Okay, so, and I wrote down what I did here. And you told me I need to write more for that?
I just, how to get the uncertainty of the slope, like the formula. Because
Or do I need to write it as a formula? Because I wrote it as words.
that would be, oh no, your words are good, but you would need a formula as well.
So under that, I could just write the formula for it.
Where, yeah.
Average.
Yeah, and did you explain what a residual is?
No.
This is what I mean.
Okay.
I mean, what you wrote is true, but to somebody who doesn't know how to get the uncertainty of the slope, they're like, well, how did you get that? Is it, oh, well, it's simple, I just used the residuals. Like, what the heck's the residuals, you know?
Yeah.
So this is what I was trying to get at when I said it's not long enough. You need to explain how, not how, well, yeah, how to calculate this. Because there are many ways to calculate the uncertainty of the slope. I provided you with one way.
You meant for this one, you said don't split it over
Yeah,
two
I have.
pages.
I do.
You mean the tables or if I had this part there?
So, wait.
Yeah.
That's what you meant? I
Yeah.
just,
You put it down. Yeah.
That's
That's it.
Oh,
You mean the weights here?
Yeah, I can't see any weights in the picture.
And what do you mean don't split?
Oh, in my version, that was over 2 lines. It had 1700 on one line and then 4 grams on the next line.
Yeah.
So yeah, when you print it, make sure you're not printing numbers and units that break over 2 lines. Yeah, just
Do I need
keep it simple. Sometimes simple is good with the English.
Yeah.
Yeah.
And
What-
I have 3 references. I need
Yeah.
more.
If you're looking for max marks, I think the limit hits it at 6 for A star. Okay, children, you have forgotten how to calculate uncertainty of the slope?
Like, you did the average of the theta.
Yeah.
So like such for, like we have 2 acceleration, because we did the experiment twice.
Oh, Lee, I talked about this in class. Somebody asked me this. And what did I say in class to do? Because you have it twice.
You get the average.
No, I didn't say this in class. Does anyone remember? Yeah.
I did that. I was like, got the average of the velocities, not the acceleration.
Oh no, please don't tell me that's wrong. I'll have to do everything again.
I told you in the last class to plot both.
But you can't.
And that's what you said last time as well. Oh my goodness.
We draw 2 graphs.
And that's what he said last time as well. So I have to make 2 graphs, right?
No,
Like,
this
no.
one, I'm making the other one now.
So 2 lines of the same thing.
It's like that movie where you're stuck in a loop and it's over and over again. Okay, so again, you said, what do I do about the 2 points? And I said, plot both of them. And he said, what do you mean, 2 graphs? I said, no, not 2 graphs, 1 graph. So 2 lines? I'm like, no, not 2 lines. Plot them both on the same graph. You can't, that's impossible. I'm like, no, it's not. Again, it's impossible. I'm like, no, it's not. What will happen is 2 of the points will be close together on the graph. So your graph will look something like this.
Okay.
But you can still plot all the points. It just means you'll have them in pairs. And you can still get the line.
No. You can't do that. You can't do it.
Why not?
For the same value, for the same force, you can't get 2 accelerations.
But I'm not getting to okay, hang on. Let's have an example. So you have an acceleration and you took the average of the 2 accelerations.
Yeah.
Yeah.
Okay, so let's give me your first 2 accelerations.
0.42.
Yeah, hang on, let me just put an A here. 0.42, and the other one should be close to it when you did it twice.
This is the average.
I don't want the average, I want the original 2.
Okay, the first one.
Same.
Okay, 0.42, 0.42.
Can you just change 0.4 and 0.4?
To show us.
Yeah.
No, I'll do a couple. And what weight was that? What force?
50.
No, that's 50
The
grams.
first is 0.49.
Okay. Right, now give me the next 2 accelerations, which will probably be different now.
0.79
Yeah?
and 0.73.
Okay, good. And what is the force here?
0.98.
Right, 2 more. Next 2. You can jump down. Why don't you jump to the last one?
3.91
Yep.
and 3.78.
Okay, and the force for that?
4.9.
1.47.
Oh no, we jumped to the last one. So what is it, 4.9?
0.05.
Like this.
Yeah.
Right, let's see what happens.
But shouldn't the force be the same for everyone?
No, because we're increasing the weight, the hanging weight.
Each weight you repeat it twice. So you have two results for each force. For one force you have
But I mean, like, everyone should have the value 4.9
yes, yeah.
or 5 for the force.
Huh? No.
No.
Well, just...
Only if you did it.
Yeah. If you used whatever, what was that, 500 grams.
Yes.
Now look, I'm making the scatter plot here, okay, as normal. And what's on the x? Or whatever, I don't care. X, Y. It can still make the graph. It's just neighbouring points. The points will look like they're in pairs. And look, I can still put in the line, and I can still get the equation, and I can still get the slope. So here the slope is 1.28.
So we do this.
Yes.
So what about the average acceleration?
We do nothing with the average acceleration. You mean average of the two, or average of the whole lot?
Average of the two.
No. Do nothing with that.
So wait, so in the table, so average of the lot, we need that?
Yeah, for calculating the uncertainty.
Yeah.
Yeah, you need to... This is after you do the residuals.
So this is it.
We have two
No. What do you mean two uncertainties?
We have A1 and A2.
No. There's only
There's
A.
only one line.
Yeah.
You're the uncertainty
Of one line. The uncertainty of the slope of this line. This concerns me.
What is that? This graph.
This concerns me a lot. How to calculate the uncertainty of this graph? I will do that very quickly now. I'll do that very quickly now, watch. Yes.
So if I did the average of the initial and the final speeds, and then calculate one acceleration, it's not wrong.
Yes. And is that what everybody did? What did you do?
I got the average of all acceleration.
Yeah.
And then I plot this on the graph.
I mean, if you did do that, not like your answer will be wrong, it'll be still quite close. It just won't get you full marks because you're not using the two values correctly. The reason you can't do that here, no, not that you can't do it here, the reason it's inappropriate to do that here is because you have Excel to make full use of all your data points. Whereas when you're graphing things by hand, like say Ohm's law, with the current and the voltage, then it's more appropriate to average your two readings to make one point. But it does not cost you any extra energy to use Excel to graph all your points, even the points that are very similar. But I know I said this in the last class. I know it. Deep down, you know it too. Don't you? You can kind of remember me saying this.
Question. What's the S?
I don't know, whatever I picked here, A or F, I can't remember.
A or F? So
It should be F. I don't know what I did for this graph. Can I show you how to calculate the uncertainty of the slope here? Can I show you now? Okay. Am I going to get good lab reports tomorrow?
Dun, 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 dun.
Which goes on the x-axis here? Yeah, so let me just rename that x and just call this one here y, just so I don't lose track of it. Okay, I can begin. So the very first thing you want to do is calculate the average of x and y. So I'll just put that underneath at the bottom here, average of y and then average of x. Then the next thing you want to do is calculate the residuals of x and the residuals of y. But before you can do that, you need to calculate the line. This y equals mx plus c. You want the m and you want the c. Good news. Excel can calculate m and c for you. The formula for m is slope, and it needs the y's. No, that's not the y's. It needs the y's, comma, and then it needs the x's. Close. And to get the c, that's called intercept. And again, it needs the y's, comma, and then it needs the x's. Faisal, you're distracting the students. Now, come on. If you want to record it on your phone like a weirdo, just hold it. Right, so I got the m and the c. Does anyone remember what the residual y means? The difference between, the line and the point. So residual of y will be y minus the value you get on the line, using the line. So that would be equals y minus, and we should use ABS. What does ABS stand for? Absolute, which means you only want positive. Y minus bracket, bracket, and now we put in the equation of the line, which is m. What do I need to do to this formula in Excel? Put in dollar signs. Why do I put in dollar signs? Because it's a constant. M times x plus c, which also needs dollar signs. This should be a small number, and it is. Copy this down. Now we do the same thing for x. But for x it's a tiny bit different, because when you have y equals mx plus c, y minus c equals mx, so 1 over my plus minus c over m equals x. So instead of using m and c, we have to use 1 over m and minus c over m. So again here we get absolute x minus, and now we have our formula, but this time, restart. Absolute x minus our formula, and this time we have 1 over m, so 1 over m with the dollars, and then minus c over m times, just c over m, of course. This should be a small number as well, and it is smallish. A bit bigger than I thought. Minus 1 over... did I forget to multiply by x? Or by y, a2? I think I did, so sorry. Multiply by y. That's better. I've used this formula here. I just forgot to put in the y there. Okay, now we calculate the average residual x and the average residual y, and then the uncertainty is the y divided the uncertainty is the y divided by the x divided by square root 6. Why 6? Because I have 6 points. Is that finished? No, because that's the uncertainty of the slope. But we don't use the slope in Newton's. What did we use? I think it was 1 over the slope. Because if you look at the graph, this is f and this is a. And if you have f equals ma, that's the same as a equals 1 over mf. So it's the slope, is the mass is 1 over the slope. So the uncertainty in the mass is the uncertainty of 1 over the slope, which is the uncertainty of the slope minus 1. So we can use our formula, the uncertainty in the mass over the average for the mass is square root the uncertainty in the slope over the average of the slope, multiply the power squared. You did this formula in chemistry as well, I think. So the uncertainty in the mass is the mass, and this cancels out, so you're just left with times the uncertainty in the slope over the slope. So in this example here, that's 0. That's 1 over the slope times the uncertainty in the slope over the slope. So that will be here the uncertainty in the mass. Well, let me just write both down. Mass and uncertainty in the mass. Mass is 1 over the slope, and then the uncertainty is the uncertainty in the slope divided by the slope squared. The uncertainty in the slope divided by the slope squared. So here I have 1.28 plus or minus 0.52. Now, who can tell me why is my uncertainty so large here, 500 grams? What do you think the reason is for that? I only have 6 points. How many points will you have?
10.
Well, more than 10, isn't it? Huh? Because you did each one twice.
20.
16 points, yeah. 16 points. Which will make a significant difference. So, if I change this to 16 instead of 6, it's decreased to 320 grams, for example. Yeah. Now, I did have a lecture recorded up online about this as well, and I'm sure if you go to my YouTube channel you can find it if you type in uncertainty and look for the video that looks like it's an Excel video. There's one from 2 years ago. Now please note, each year I do it slightly differently because I feel like I try to make it a bit easier each time. So if you look at an older video, it might be a little bit harder because I might do more in it. What you do here is definitely enough for the coursework. In fact, I think maybe it's even a little bit more than what they do in other centres, I don't know. But I like to do this because this is what you would do at university anyways. Yes.
For our analysis section, does this also include the formulas you were writing? Do we need to talk about those?
I would like you to talk about some of the key ones, like the one that you saw in chemistry as well. You know the one I'm talking about? Guys, did you do a lesson on uncertainty in chemistry? You had something like uncertainty in Z over average of Z equals square root uncertainty in X over average of X squared plus uncertainty of Y over average of Y squared. Did you do this in chemistry?
Most of us did the experiment that had no...
Oh yeah, I forgot you said that. So Andrew, to answer your question, the key formulas you should mention, like this one here. You know this one or not? Okay.
But did we use it? Or
We did.
We did?
Yeah, it's just that we didn't have we were just using it for this formula. Mass equals 1 over the slope. So this is like Z and this is like X. So there wasn't the Y part. And in situations where you have a power, like slope power minus 1, you just multiply inside here by the power. But because it's minus 1, it didn't matter because you square it, it becomes plus 1. So it doesn't actually matter about the minus 1 and the power here. How many YouTube videos are on my channel called Uncertainty? Just curious. Yeah, I thought maybe so. Can I see?
Not that much.
I'll do the old-fashioned way.
What about the one for the 2 months?
It will be in there, but maybe I just call it business tutorial.
No, but you should record this one.
What? This is recorded now, it should be uploaded today. Yes, it is so. Guys, when Juan typed in uncertainty on my channel, the first 2 results are a tutorial from 2 years ago on how to calculate it, and a tutorial from 1 year ago on how to calculate it. And you also have this one now. And I already showed you in class maybe 4 weeks ago, before the holiday, how to calculate it. So the way I see it is you have 2 videos and 2 lessons on this. It's due tomorrow, isn't it?
Oh, yeah.
Yeah, because you could have fooled me. Guys, how am I supposed to sleep at night now? How am I supposed to sleep tonight knowing that you'll be up until 3 a.m. finishing this?
I have an idea.
Yeah?
Not applicable.
What?
Postpone it.
Good one. Good one. Is that like a Ramadan joke or something? I don't know.
Good idea.
What? Guys, come on, I gave you loads of time for this. When did we do this? When did we set this? Like 4 weeks ago or something. I hope you're learning a valuable lesson about the importance of planning your work.
I have a question.
No, none of you are. Yes?
How do I need to add X, the title of X and a title of Y?
Yes, of course you need a title of X and Y. And units too!
How do I do it?
No.
No, I'm serious.
We had this conversation in class before. And then I can't remember who it was, like Yusuf, wasn't it? You showed him how to add in label titles, didn't you? Yeah, he showed you how to do this in class already. So ask Yusuf.
I have a short homework. He's doing his work. You want to distract him? He's not doing anything. You can save time right now and tell me.
What does a nervous breakdown feel like? Just What? Do you want to put in the titles?
Yeah.
There's a tab up the top, format or design. It's one of those 2. Design. No, go right. There, design. There, now look on the left. Is that add chart titles? Yeah, axes. Yeah, now how long did that take me? I don't even have a fancy pants Excel like this. I use Ubuntu here. You give up so easily.